All right, welcome back. In this problem, we're going to find the area of the red semicircle, knowing that we have a right triangle where one side is 8, the other side is 15, and the red semicircle is tangent to the hypotenuse. If you want to try this problem on your own, pause the video because I'm going to solve this problem in just a few seconds. Okay, here we go. First thing I'm going to do is I'm going to find the hypotenuse of the triangle by bringing in the Pythagorean theorem. Okay, so I brought in the Pythagorean theorem, and we are going to do leg squared plus leg squared is equal to the hypotenuse squared. Okay, so now I'm going to put 17 over here on the hypotenuse, and then I'm going to bring in the concept of the two tangent segment theorem. So what the two tangent segment theorem says is that the tangent segments drawn from the same exterior point have to be congruent to each other. So if this one here is 8, then this length right here, from here to the point of tangency, is also going to be 8, which leaves the remainder of the hypotenuse to be 9. Okay, we have the center of the circle here, and now what I want to do is I want to draw the radius of the circle to the point of tangency over here. Okay, now we know that this radius to the point of tangency has to meet at 90 degrees. Okay, and this segment right here we're going to call x, and that's a radius. This here is also going to be x. It's another radius. If this is x and the bottom is 15, then the length from the corner of the right triangle to the center of the circle is going to be 15 minus x. And now what I'm going to do is I'm going to do the Pythagorean theorem again, but I'm going to use this right triangle down here. So we're going to clean this up, substitute it with our new values, and do the Pythagorean theorem. Okay, so our new Pythagorean theorem values are going to be x squared plus 9 squared is equal to 15 minus x squared. We're going to multiply these out, FOIL that. Okay, now that we have that, we're going to solve this equation. Each side has x squared, so we're going to subtract away x squared from both sides. Okay, I'm going to move the 30x over to the left-hand side by adding 30x to both sides, and at the same time I'm going to subtract 81 from both sides. And if I subtract 81 from both sides, it's going to be 144. I then want to get x by itself by dividing both sides by 30. So when I divide by 30, I get 144 over 30. I'm going to reduce that fraction, and I find out that my radius is equal to 24 over 5. Okay, so that's an important number. I'm going to move that right over here. So I cleaned it up, and I'm going to now write the area formula for a circle, which is pi r squared. But we don't have a full circle, we have a half a circle, so what I'm going to do is I'm going to divide it by 2, which is the same as multiplying by 1/2. So after I plug my values in, now all I have to do is simplify this expression. Now I'm going to take the 1/2 of the 576 And once I simplify everything, I find out that the area of the red semicircle is going to be 288 pi over 25 units squared. That was a really cool problem. If you enjoyed this video and like to see more, please smash the like button and subscribe to my channel. I will see you on the next video.